Hello, Internet. So last time we built this. This is our voxel terrain. It's a 3D cube of voxels, I guess. Um, doesn't work very well. It does work. I mean, this is what we get. But there's a few things. One of the advantages of recording all of these is I actually get to kind of watch them back when I'm editing all of these and kind of see what I did wrong and why things didn't go exactly right. And in this case, there's some pretty clear issues. We're gonna fix those. That's what we're gonna do here. So there's two big things I want to do. One, updates are terrible. This doesn't do updates well at all. And two, I want to get lighting working. I want to be able to use Unity's lighting in this. I don't know if that's going to be a long-term solution, but that's sort of what I want to do. Specifically, I want to just get normals added to this. So they're all publishing their normals. I think that's going to be really easy, but I don't exactly remember how meshes handle normals, so we're going to figure that out through some trial and error. That's what we're going to be working with. So the first problem, probably should have caught this initially because it's, looking back, it's obvious, but I totally missed it, and it's just a thing. This is bad. So what this is doing is sending a block update message to every component on this game object every single time any block gets set. This is a problem because it gets called once for every single block. And the result of this means we generate a mesh. That means for this 10 by 10 by 10 block, we generated 1,000 meshes. Only one of those was right. So in a single frame for this update to generate this, we created 1,000 meshes and got rid of 999 of them. Why? there's no reason to do that. Two, send message is kind of good and bad. It has to kind of go and do some searching and find all those things. I want to use events. C# has events built into it, so we're going to just kind of build off of those. So that's sort of where I think we're going to start. Public event. Let's call it a Unity event. Right, those are things. Okay. It's been a long time since I've done Unity events. They're exactly the same as C# events as far as I know. We can test that real quick. Base event. Nope, there's something entirely different. Never mind then. I thought they were based off of Unity's event or C#'s events. Apparently not, but we're going to use them anyway. So, can't call it event. Event's a keyword. So we're going to call this on block update. So this now is what's going to get called, which means that things actually need to register with the chunk they want to monitor. If that makes any sense. So we have this chunk mesh generator. It's no longer going to have its block update get called. It's actually going to need to subscribe to that. So in its start, we need to var chunk equals get component of our chunk. Ooh, there's a space there. That's not supposed to be there. There we go. So this is going to grab our chunk, which means we need to require one and not freeze. There we go. Add a chunk. We'll pull that off, and then chunk.on block update plus equals block update. So I just want to invoke our block update with the chunk we got every single time we do that. And so there has to be a chunk, otherwise this really isn't going to work. So, ooh, that's not right. Let's just add a quick error message here. So if chunk is equal to null, then should we throw an exception or log an error? I think we should throw an exception. In Unity, this matters less because it doesn't actually crash your game. It just gets caught. Throw new the exception. No chunk found for mesh generator. Sure. This is wrong. Doesn't have a lambda expression. Okay then. That's a shader. We don't want to go there yet. In here, block update. I don't really remember how Unity events work. Invoke add listener takes a Unity action, which is a delegate. So can I really not do that? Do I have to actually add listener? Do I have to do this? This is kind of not nice. I don't like this. Okay. There's no overload for the plus equals, so we're just gonna have to do this. And so this will subscribe our mesh generator to our chunk, which means we're exactly where we were to begin with. We didn't actually gain really anything from this. On block update dot invoke. Cool. So that's just going to update that. We're not actually going to send any data with that anymore because we don't need to. Again, when we have something that actually has an update, we can send that. But for now, we don't need to. The difference is we are going to add another setter. Fill blocks. And that's going to take a triple array, again, of our blocks. And we're actually going to fill it with colors. So this is literally just our blocks, our block data. And so we're going to do the exact same thing. We are going to fill all of this with everything from here. One other thing, I forget who mentioned it, but they brought up the fact that we were actually iterating over these wrong. Not wrong, but just in a less than optimal way. So we were doing bar x equals 0, etc. It's actually better in this case to go backwards because the way this works is you have an array in an array in an array. For large arrays, what can happen is think it's easiest with a double array to think of this, but effectively you have a group of groups, and so every thing to the right is the internal group. So in this case, our Z, which is the furthest to the right, is the furthest down group. And then everything above that just goes up higher. So what ends up happening is if we start with X, we're going to have a bunch of cache misses because we're going to constantly be switching, moving the biggest amount of memory. Because we're skipping over the group and the subgroup and just going to the subgroups or the parent group. If that makes any sense. That's not, for small things, it's really not a big deal. But if you start dealing with a lot of data, what can end up happening is every single time your computer's going to load in, like, I don't know, maybe 100 elements. If it loads in 100 elements and your group is 100 wide, theoretically, the entire thing could end up in memory and you would be perfectly good. But if you are actually doing it with the way I'm doing it right now, you would skip all of those and actually cause a cache miss every single time, which means you have to go and reload all of that data every single time, which is just going to be slower. It's sort of a micro optimization, but it's an optimization. That was a lot of stuff on that, but anyway, there we go. We're just going to increment all of these and just effectively fill this. I'm doing this as sort of a copy. So it's going to be sort of a shallow copy, a shallow clone. So the array is not going to be the same, but the values stored in it will be, which means you can actually send this array over and maybe persist it or change it later. And it won't get reflected on the chunk, which means that you can't miss things. What we would have the possibility of doing is if I didn't copy this stuff over, it'd be possible for us to send all this over and then whatever was handling that array could change some values in it. And then our chunk wouldn't update. And so to avoid that, we're copying things. Theoretically, we could actually create a copy of the color or block as well. But at this point, we don't really need to, so it's just more work. So chunk data x, y, z equals our block data at x, y, and z. And so there's just our copy, and then we have our on update. And there you go. Now, theoretically, this should actually update everything and hopefully be a lot faster. Assuming I have everything actually hooked up correctly, which is kind of a big if right now, but we'll go with it. Also, I didn't actually do the thing, so this isn't going to be any faster at all. But, So, we're going to start this. It's totally failed. Nothing's happened. And I'm pretty sure, yep, it totally thinks it's done. Well, that's no good. We definitely did not do the thing that I wanted. Was our listener invoked? It should have been. Unless, hold on, our chunk generator is in the start. So this needs to be in our awake. Just a timing issue is my assumption, because this should generate a mesh. It should do the exact same thing. Won't necessarily be great because we don't actually get any optimization. We're not calling the fill anymore, but at least we still get this. And so hopefully every time we get the exact same results, because that's what our seed is for. And so we should just keep getting this over and over and over again. If it changes, we've probably screwed something up. It's not really a great test, but it is a test. Granted, a manual one, but whatever. So the final thing to make this whole thing actually better is to use that fill. So instead of this set block here, we need to call the fill, which means we're going to actually persist an entire chunk and then copy it over. So color, ooh, that's not right. Color triple array of our blocks equals a new color of our chunk.width, and the chunk.width. We might want to actually have the chunk give us this information and kind of work off of that, so it can actually create this block thing for us. That may be safer in the long run, but for now we can kind of work with this. This entire chunk generator is going to probably go away pretty soon. The mesh generator we can build upon, but this probably doesn't have a very long life on it, so we're going to kind of make this scrappy and make it work, and then do something better later. All right, so blocks, we were switching these, so let's just do that. We just need to switch the Z and the X. So it doesn't have any functional difference. We're still iterating over everything. Again, it's just a micro optimization. Kind of helps with, yeah, cache hits, which I guess with this kind of matters because we're doing this a lot theoretically. But yeah. All right, blocks. In here, instead of doing this set block, we are going to do blocks of this. Ooh, that's not right. Equals our color. So that's just going to actually set it. And then where's our endpoint here? So then we want to do a chunk dot fill with our blocks. And I think that's it. So this way we generate everything here, and then we fill this out and actually get it all working. So hopefully this means there's a single update, so it should generate 999 less meshes. So hopefully this goes way faster once it compiles. There we go. Ooh, that's not right. I have screwed something up. Oh, also our mesh is going to change now. I talked about the testing thing, but we totally screwed this up because I switched the order it iterated in, which means our mesh is going to have different values because now we're iterating on the x-axis first instead of the z-axis. So that's just going to change things. It should just kind of rotate it if I'm correct, but I never know if I'm correct or not, so who knows? All right, x, y, z, that all looks good. X, Y, Z, X, Y, Z. Oh, there we go. I was iterating over the wrong thing and not incrementing x. Oops, copy and paste. So, hopefully now, that's not right. Did I do the same thing? Is it it looks like it's the same thing. Yep. Y and Y. There we go. So, screwed that up twice. That's not great, but So, with this, hopefully what we can do is get our mesh back. It looks good. And now, hopefully it's faster. It's hard to tell. I don't know a good way to do that, except we can Perlin chunk generator, chunk mesh, block update, debug, log, updating mesh. This will let us know every single time it updates the mesh. We probably want that anyway, just because it's going to make it easier to tell when things are actually happening. But yeah, we should see it once, which is good. It means we only updated this once. That's better than it was. So, what do I want to do now? It's also interesting, even though we do add an event on here, it doesn't show up in the inspector. That's interesting to me. I'm not sure what I expect there, but it's interesting that it doesn't show up. So, now that we have that, let's add some normals to this. That's all in our mesh generation, which is here. What's the best way to do this? So I'm thinking, not sure if correctly, but I'm thinking we don't need to do anything here. If I remember correctly, again, which I probably don't, I think we can just do mesh.normals equals our generated vertices dot select. We need link. There we go. And we are going to take our vert and return a vector3.forward. Like I said, not sure this is correct. Pretty sure this isn't. But what I think this is going to do, or what I'm thinking it's expecting, is a normal based on the face. If that's correct, then this will work, and we'll always get normals facing out. Otherwise, this won't work at all, and we'll actually need to add something up here to give us normals. But if it does work, we should see some shading. Meh. Hard to know. Clearly, no. That did not work at all. There's no difference. I should also probably check if I'm using an well, hold on. Before we go down this whole rabbit hole of screwing everything up, let's just have a, woo, that's not right. Let's just have a test material. And we'll just throw that, ooh, that's kind of interesting. Yeah, so why do we have lighting here? And not anywhere else. Cast shadows. We probably aren't going to get self shadows on this because I don't think that's how that's going to work. But we might. Not entirely sure. Why do we get specular highlights there? So I'm seeing the specular bit, which is that like brighter line right in the center of the screen. I'm wondering why this shader doesn't have it. And I'm not entirely sure. Diffuse, all of that. We have a metallic and glossiness. Am I using the right thing? No. No, I'm not. That explains everything. There. Okay. This is much better. I mean, it's not really that much better, but it's better. So now we actually have these colors, which is good. And it's not behaving like particles, so we had some like Z fighting and stuff, like you could see this green block through things. That was because we were using a particle shader. That wasn't because of anything I did. Okay, that's reassuring because I was getting really confused. It also cleans up all the mesh stuff that we were seeing. It looks a lot more uniform here, which is good. It makes more sense. So, I don't know. I don't think that normals did anything here. We can check that, but I'm pretty sure doing that had absolutely no effect. Yeah. Didn't do anything. Which means that I need to go in here and do a var generated normals equals a new list of vector 3 blarg, and we need to actually pass these normals in to this fun function. Great. I don't want to do any of this. This is getting gross, but we're gonna do it. And then so what I like to do with a lot of this stuff is kind of make it gross and then fix it. The fixing it is important. I don't always show that here, but usually I write things kind of sloppily initially just to kind of get ideas out there, and then kind of I don't know, it's like a puzzle. You kind of get all the pieces out, kind of connect them in little pieces, and kind of get those ideas, and then you can kind of see, oh, there's something here and this can match that and so forth. That's what I try to do. It seems to help, but sometimes it just doesn't work. So, generated normals dot add, and then we need to do our xdiff, ydiff, zdiff. I think. I'm trying to see if we have any differences in position, and it doesn't look like it. So what I'm going to do is take the adjacent position plus minus the current position, which should give us a vector facing the adjacent position. So it should face out of wherever the thing is. I think that makes sense to me. We're going to want to normalize that. So we'll just throw that in parentheses and everything should kind of sort itself out. There we go. Let's also just save this. Var normal equals that. That way we don't need to do this math 4 times. It doesn't make any sense to do that where it's the same value. So since this is a flat surface, all 4 normals should be the same. They should all point in the same direction. If they don't, I've done something wrong. So that's sort of what I'm basing this off of. And we'll know if we get it right because it should actually react to the light correctly, which I don't really know how to tell. Suppose that's probably a good thing to figure out. Ooh. Do I have culling off, or is it just oh. Okay. One more thing we're gonna fix in this video. I talk about triangle winding. You can definitely see that here. It affects what is the front and what is the back. This is OpenGL, so it should be clockwise, if I remember. That might not be the case, but think of winding like taking, if a triangle is 3 points on your clock, if the triangle can be 1, 2, 3 in a clockwise orientation, then everything's good. It's the front face. But if you actually look at that same triangle from the back, counting those vertices by index, they'll go counterclockwise now. And so if that happens, then you know you're on the back face. In most GPUs, that means don't draw this. What's ending up happening is I've turned that off, but our shadows are still calculated as if they were culled. And so we're getting really weird shadows. This is all based on a guess, but hopefully an educated guess. That's what I think is causing this to happen. So what we're going to do is first cull back. We actually don't even need that. We're going to turn that off. Bye. So that can just go away. There. So these are the actual faces. Now, what I want to do is fix the other one. So in this mesh generation, we add our triangles. One of these two is wrong. I don't know which one. So we're gonna move one of the vertices. And so that should switch one of them around, which means it's now either changed from clockwise to counterclockwise or from counterclockwise to clockwise. I don't know which one. Also, that is, oh no, no, don't do this. Oh, that's not good. So it changes based on the orientation. That's less good. I would go so far as to say that's bad. Because now I need to figure out the orientation in order to figure out how to do the triangles. So I imagine if any of these are negative, then everything's bad. Dang, okay. This becomes harder. So what is the solution to this? We can do, hold on, generated triangles dot add range. So I can take this and add the range. I think that might be the best way. So this is probably, I think, negative, going off of an educated guess. Not really educated, just a guess. But I think we should be able to do this. It's going to be a little bit gross. Triangles equals new list vector 3. There we go. And now here, generated triangles dot add range of our triangles. There we go. It's fine with that, so that's good. It's not fine with that. That's not good. Oh, it's expecting ints. That's an easy fix. There we go. All right. So winding. I think that if xdiff is greater than 0, or ydiff is greater than 0, or zdiff is greater than 0. So remember, there's only going to be one of these that has a value greater than 0. Oh, and I don't save the difference. We should do that. All right. I'm going to pretend like this is a thing. And we are going to do that. Else, we are going to do the other one. Actually, no. Ha! We can cheat even more. So let's do this. And let's make this a triangles. And so that will configure our triangles. If it's the opposite direction, we can just reverse that array. Dot reverse. Right? I think that works. So that's just going to turn everything around and spin our list in half. I think that makes sense. And that way it's sort of less work. Current index, we're going to need to move you up or move you down. We'll move you down. Yeah. Kind of just riffing on this. I hadn't really planned on this part yet, so we're figuring it out. But xdiff, ydiff, zdiff. We need a diff. Vector3 diff equals our block minus our adjacent, or our current minus our adjacent. Current position minus our adjacent position. Yeah. And then diff.x, diff.y, etc. That's not right. Diff.x, diff.y, and diff.z. So those are greater than reverse this, and that will flip this around. Hopefully that's the easy fix. There's going to be a better way to do this. Since this is sort of riffing, I didn't really know what to do. But I suspect that you could do something with like cross products, for example, and it would work much nicer. Back faces. Everything is a back face. Huh. Well, we're gonna cheat a little bit, just a little bit. So currently our camera is facing this way. I need some perspective here. So scene view. There's that. Those are front facing. No. Yes. No. Hold on. Yeah. Okay. So from this perspective, we're seeing all the wrong sides. So when z is negative, we're seeing all the wrong sides. So this is the wrong direction. That's sort of how I'm just going to look at this. This is correct. So this will be x. X is the correct side, but behaving oddly. Oh, nope. Just again, the z is flipped, so that's what's wrong there. Also, it froze. There we go. And then y appears correct as well. So just z was the only one wrong. So theoretically, switching that sign should fix everything. Which means if I regenerate this now, hopefully all the sides kind of work. Looks better. Awesome. There we go. So that makes a little bit more sense. All the windings appear correct. It's good. We could probably do a little bit better solution than that super hacky way, but it'll work for now, and we can kind of figure that out later. And now our voxels have shadows. So that's cool. So now we have shadows. Things generate a little bit more efficiently, which is great. We can probably do bigger things. If you do like 25 with the old solution, it would take quite a bit longer. It might still take a bit with this. I don't know why I tried 100 previously. That's like a million things. That's just huge. But 25 should. I'm probably going to... Oh, that's actually really quick. Should be pretty quick. There you go. So there's 25. I shouldn't have done this because now it's broken and I have to fix it. What happened? All right, well, that's odd. There's sort of these single triangles that are stretching across like the entire thing. It's almost like we have off by one indices or something. And I'm not sure why. this side looks fine. And this side looks fine. That actually looks really cool. There's like a cave here. Awesome. All right, things are looking good ish. I'm gonna pretend that didn't happen. And let's see here. How do I make my light better? There, and we'll do something like that. Sure. All right, let's try this again. Maybe it worked. Maybe it didn't. Why is it so hard to get good lighting? It's like not even having any effect until it gets to like that perfect point, like there. That's really weird. I don't know what's causing that either. But this isn't right. This isn't right at all. But it's only this side. So my guess, and it also looks like it's just this. So this is our x equals 0. Does that happen on smaller sizes? I'm curious if that's just like a 25 thing or if that's a every size thing. So if we run this now, there's our camera. So this is the side we care about. I don't see any issues there. If we do like 12, kind of curious because I don't know what that would be off the top of my head. And it looks like it's just that 25. That's no good. 24? Have less issues. Don't make me fix you. I don't know what's wrong. I'm very confused why it only happens once. Is it 25 like some special number? Does it happen when it goes above? No. Oh, what the heck? I don't know what that is. I don't know what causes that to happen. And I honestly, I wouldn't even know where to start. It's off by 1 is my guess, but I don't know. Is there an error? When I do 25, is there an error that I'm not seeing? Maybe. No? Okay. I don't know. So that happens. I'm gonna search and try to figure that out. We'll do another video once I figure that out. But I don't know what that is. I don't know. But it does much bigger things. We're gonna try 100 again. I'm gonna regret it again, but we're gonna do it. And we're gonna see what happens. Hopefully this actually just works. That would be fantastic. I don't think it's going to though. I think we're still, oh. Well, I reproduced the error. That actually looks really cool. It's missing a bit. All of this bit is missing, but So what's confusing me here, I'm guessing we ran out of vertices. That's my guess. Or we ran out of things. Because at previous Unity, you could only do like 64 vertices. I imagine that's what we hit. But Unity 2018 was supposed to remove that. Maybe I'm not on a newer enough version, but that was sort of my guess. But that clearly didn't work. So we're gonna drop that down to like 50 and make something just as cool, but less breaking. And then I'll call it done. Same issue. We got more, but it was the same thing, like 5 and a little bit of change. Okay, so that doesn't work either. I was sort of expecting we could go higher, but apparently not. So I need to figure that out as well. But it doesn't freeze my computer anymore, so that's a plus. So I guess we made this significantly faster, especially with the 100. We would have generated like a million extra meshes that we didn't need every frame. Oops, we probably don't want to do that. So this is, like, I guess, a better solution to the voxel stuff. We can expand this further. What? Okay, that is the right size. I was just really zoomed out. But there you go. It's sort of the Minecraft style. My light keeps going in the wrong place, but it does have shadows, so that's cool. And so you can actually use Unity's lighting. I should be able to just add like a sphere or something, and it should do normal sphere stuff. No collisions, no anything like that. That's other harder work, but we're not there yet. So bunch more to do with this. I want to get like a tile set so we can actually add some textures to this. I think that'd be really cool. And if there's other suggestions you guys have, we can try those as well. But that's it for this video, because I've kind of just screwed around with this enough. But if you guys have other ideas, let me know, and we can take a look. It doesn't have to be voxel stuff. If you've got other projects, whether that's cloud stuff or IoT stuff or more Unity stuff, we can take a look. We have a Discord channel. You can come and join that. It's in the description below. I'm trying to set up some live stream stuff. It's been hard, so hopefully I can get around to that as sooner. Once I do, I have some fun projects, but I think it's best to just do them on a live stream. I think they're kind of suited for that. So once I get that sorted out, that's going to happen, and then we'll do other stuff. So yeah, that's it for this video. So until next time, see you, internet.